Hey guys, Sukanya here. In today's video, we are going to be taking a look at how to solve this integral, integration 0 to 1 of root 1 minus x over 1 plus x dx. And in order to solve this, I'm actually going to simplify this part of the integral. So I'm going to rewrite it as 0 to 1 of root 1 minus x over root 1 plus x dx. And the reason I'm doing this is because I know whenever we are dealing with square roots, I want to get rid of at least one of these square roots. So in order to do that, I'm just going to multiply both top and bottom by root 1 minus x and then root 1 minus x dx, because when I do that, this gets rid of the square root. So the bounds are going to stay the same, but the top is going to be 1 minus x, bottom is going to be 1 minus x squared dx. From here, I can't really simplify it anymore, so I'm just going to break this integral apart into two integrals. So that would look something like 0 to 1, 1 over 1 minus x squared dx minus 0 to 1, x over root 1 minus x squared dx. Now, we have to solve two integrals essentially now, but they are in a form that is less complicated than this original integral, so we're getting closer. So I'm going to solve this integral first, and lucky for us, we have some special integrals that I discussed in an earlier video. If you haven't watched that, I'll link it in one of the corners on your screen. But using those formulas that I go over in that video, we're going to be using this specific formula, this expression right over here. So we see that this integral looks a lot like this integral over here, and in that case, a is going to be equal to 1 and x is just x, because a is always the constant. This matches up with that, and x matches up with x. This integral is going to become, remembering those bounds, we still have 0 to 1, so that's going to be sine inverse of x over 1, 0 to 1, and I'm going to leave this integral as it is. Alright, so let's solve this. Solving this, we get sine inverse of 1 minus sine inverse of 0, rewriting this as it is. And then this is equal to pi over 2 minus 0. And from over here, there's not a specific formula we can apply over here, but I do know that if I wanted to hypothetically set u, because we're doing u substitution, equal to 1 minus x squared, so basically equal to this part right over here, then du would have to be equal to minus 2x dx. But unfortunately for us, we don't have a minus 2x dx in here. What we do have is a x dx over here. Lucky for us, x dx is equal to minus 1/2 du. What we can do instead, I'm just going to get that 0 out of the way, we can do minus integration, and I'm just going to leave the bounds as they are right now. I'm going to change them into the terms of u later on. But I know that x dx, we just said that's equal to minus 1/2 du, minus 1/2 du, and I can take that minus 1/2 du out, so minus and minus become positive, and we have a 1/2 integration. We establish that this is already du, and our bottom would be root of u. And now for the bounds. Bounds are going to look a little something like this. So when x is 0, u will have to be 1 minus 0 squared, which is just 1. When x is equal to 1, u will be equal to 0 over here. So the new bounds are going to look a little something like 1 and 0, but of course we can't have that. We actually have to switch those signs. So we are going to be left with pi over 2 minus 1 over 2, 0, 1. Remember, if we want to switch this bound and this bound, we have to have a negative sign outside of the integral. And then we have du over root u. We can solve that pretty easily. And this is just going to be 2u 1 over 2, 0 to 1. And I'm going to substitute in the bounds. So once again, we can take that 2 out because it is a constant. If we take that 2 out, this 2 and this 2 get canceled. All we are left with is just a negative 1 outside. So just a negative over here. So negative inside, we're going to have 1 minus 0. Simplifying that, we get pi over 2 minus 1. And that is our final answer.